I know a couple of you guys had questions on homework. Yeah?
7 times 7. 58. And 78.
Oh, yeah. This one sounds... This is actually one of the easier problems in here, but it just sounds like it should be difficult. You determine the number of foxes in King County. They catch 25 foxes out of the whole population, right? So they go out and they randomly catch 25 foxes. So they could have caught any fox that was out there. So they caught these 25 foxes specifically, released them, and they kind of mingle, right? This is actually very much statistics right here. Later, 36 foxes are caught. And 4 of those have tags. So they tagged 25 foxes out of the whole population. They caught 36 foxes later, and they see that 4 of those have tags. So how the hell do you set this thing up as an equation? So what do they see from what they caught? They see 4 foxes out of 36. They see 4 foxes out of 36 that have tags. And they know, what did they set up in the population? They gave 25 foxes tags out of how many? I don't know. And then you saw. Right, so it ends up being a really simple problem, but 2 reasons why it's after all these more difficult problems. And when you read it, you're like, how the hell does that even go into a equation? But this is exactly, this proportion they're going to assume is the same as the proportion for the whole population. Is that exactly true? No, this is an estimation, but this is how you set it up. Does that kind of make sense? I mean, there's reasons they tag things so they can track them and see how they migrate and move around. But this is another reason why they do it, so they can estimate the population. How the hell did they know how many freaking foxes are out there? There isn't some guy going, did I count you? You look familiar. No, thank God, right? They do something like this. It's always an estimate. There's no way to possibly know for sure. Just like humans, census is always an estimate. Thankfully, they don't tag us and release us back in the wild. That I know of. Yeah.
And the question is, how many of them were?
No, the question is, what's the size of the whole population? So if I did 25 foxes out of the whole population, I could have caught any fox. So it's 25 foxes out of the whole population. That proportion that I can set up, this should be the same as the ratio of the foxes that I see tagged to the whole foxes that I catch. Does that make sense? I mean, you can imagine, I can just see this big yard full of like hundreds of kids. And I give 10 of them something. What do you want to give them? Maybe nothing sharp. Cookies. You know, that would disappear. I give 10 of them little plastic balls, and that might disappear too, but let's just say little plastic balls. And they go out, and then I capture 10 of them, and I see that one of them has a ball. I can kind of estimate how many kids are out there. They've all ran around, they're all mixing. You with me? So if I catch so many, I can kind of figure out how many there must be total. That would be exactly this kind of problem here. So if I had a problem, I have, I don't know how big my kid population is, but I give 10 of them a ball. And then later I catch, 20 of them, and I see that 3 of those kids have a ball, right? That must mean that the 3 out of 20 kids from the population have a ball, so I can work backwards to figure out how big the population must have been. 10 out of the whole population to have a ball. I see 3 out of 20. So what must the whole population be? I can just solve this equation and figure it out. That ratio should stay the same.
That's just rough estimate.
Rough estimate. I love it. That's assuming that you've given enough time and there's enough random, they move randomly. Hopefully they don't all stay together. We're the ball kids. We're just going to walk together, you know, and everybody's like, those are the ball kids. Hopefully they mingle, right? Or else people just take them away. Give me the ball. No, you give me the ball. And they just kind of go somewhere else. Is that foxes obviously would have more reason to spread out, right? Yeah.
17.
And did you have another question too?
Same one.
Oh, 78? Oh, all right. So I was talking to somebody else about this. And again, this is in the synthesis section, in the basically extra credit section almost. This problem says 1 birth every 7 seconds. There's 1 death every 13 seconds. And there's 1 new international migrant every 27 seconds. So overall, how long does it take? How many seconds does it take for a net gain of 1 person? That's what the question asks. One thing I'll point out, I want you guys to try this problem out, but one thing I will point out is, what's the difference between these two and this one? This one's going to be somehow a minus, right? We're losing a person here. These two will be positives. And it sounds like it should be some kind of a work problem, possibly. All right, so I'm going to let you guys... it'll be all right. So I don't know if you already realized that should be negative.
Yeah.
Right? Okay. Yeah.
Can you do 30 in the same section?
Oh, okay. So this jet travels 460 miles per hour in still air. Right, that's the one you're looking at. 460 mile an hour in still air. It travels 525 miles into the wind and 525 miles with the wind, in a total of 2.3 hours. Find the wind speed. So obviously my wind speed will be X. It's the thing I don't know. But how do I set this up? What can I use to help me organize this problem? A little chart. I've got into the wind, so against the wind. And I got with the wind. Rate times time equals distance. And then it's just a question of putting all the parts in the right place. So I know it goes 465 mile an hour in still air. So how fast does it go when it's going against the wind?
Minus 46.
It goes 460
Minus 4.
minus X, right? This is going to have to be, going against the wind. The wind's going to slow it down so much. And if it's going with the wind, it's obviously going to be going 460 plus X. Now, it was for a total of 2.3 hours, but the thing I know exactly is how far it went. In each case, it went 525 miles, right? So what do you think this is going to help me do?
Time together.
Yeah, this is going to help me set up the equation. If I can get an expression for what each time is, I know that they have to add up to be 2.3. That's the part that's going to help me set up the equation. Once I get only 2 boxes left undone, I just work it out. Rate times time is distance, so time equals distance divided by rate. So what would I put here? Distance divided by rate? 525 divided by 460 minus X. This will be 525 over 460 plus X. And when you add those 2 times together, it better be 2.3. So the last time we did one like this, we saw a couple examples where they were equal. It took the same amount of time, or it was the same distance, or whatever the hell it was. So we set them equal to each other. And I said there could be problems where they add up to be something. There's one of them right there. So if I take that time plus that time, I've got to get 2.3 hours. So on one level, I really want you to understand. There might be so many guys that are like, where the hell did he get that freaking thing from? Where the hell is that from? Well, I know that. And I basically know this. It's going slower against the wind, so I can work out how fast it's going. I don't still know what it is, but I know the rate is this, the distance is this. I can automatically set up an expression for the time, because there's a relationship between these three. So I have what the time is for the first part, the time for the second part, should add up to 2.3. Yeah.
Section 6.5 and the total, number 30.
Oh yeah. Oh yeah. 6.5 in the blue. What's it say? Okay, it's plus on this bar too. No, it's minus. Minus that. Looks familiar. So this one is actually. Hopefully you start to look at these a little less like they're really horrible. The really nice thing here is there's really only two fractions I care about. There's one big ass fraction, that's fine. It's the small ass fractions that we're worried about, right? There's only two of them, so what's the LCD going to be? A minus 1, A plus 1. You're going to have both, right? So then you're just going to multiply, or whichever way makes more sense. I'm just going to multiply top and bottom by that LCD. And I highly recommend that you actually put it right next to everybody, because the next thing I would do is just distribute it to each piece. Is that cool? So I just immediately put that next to each piece. Just doing all right. Is that cool? We're allowed to do that the same reason we're allowed to multiply both sides of an equation. I have two sides to balance me out. I have the same thing here. I can multiply top and bottom by whatever I want to, except 0. So what happens here?
A plus 1.
Yeah, the A minus 1s go away.
Yes.
You get an A plus 1.
Yes. Plus.
And plus, you just have to deal with
This here.
all that
Over.
over.
A minus 1.
Yeah, the A plus 1s go away.
Yes.
It's the A minus 1
Minus.
minus.
All of it.
I was helping one student out with this earlier, and they actually have a way they do it in the solution manual. I want to try to do it the other way, just in case you don't see what you could do. So anybody, just let me ask, anybody see what you could do here?
I use a helper fraction. 1 multiply. Like, see how you do that, and then just put that 1 under there, and then just find the LCD for all those and come up top, and then just.
Yeah, so so here, I mean, if I wanted to give him what he needs, he would actually get the A plus 1, which he did get. So I don't know if that's, but what can I do to clean this up next?
Multiply.
minus.
Yeah, okay, good, we'll go with it. So if I FOIL this out, the really nice thing about that is it's
A squared.
Square minus.
It's just the difference of squares, putting it back together. On the bottom, you gotta be careful of this guy. Minus is always find a way to screw us over. So it'll be minus a squared minus negative 1, so it'll be minus a squared plus 1.
Yes.
So far, so good. So this is just cleanup time now. Distribute, get your terms together, and then see if it can cancel down somewhere. So then I get, what do I have on the top? I got a squared plus a, the 1's cancel. On the bottom I get a minus a squared, the 1's cancel.
Take A outside.
Yeah, I can take an a out of the top, an a out of the bottom,
And then just
Cancel
put the negative
A.
1.
cancel a's.
Minus 1.
So it'll be A plus 1 over 1 minus A. Free. Yeah, okay.
We're good with 25 on the same page.
Another question.
On this?
Yeah.
And then we'll do that. And then we'll do new stuff.
I hear we can make just -1, the last line.
Here?
Yeah.
No,
Why?
because it's not negative.
Oh,
The A is negative and the
Yeah.
1's positive, so you have to maintain that idea, yeah. Okay. So what was that, 25 where?
Same page.
Oh yeah, that looks gross. And it is gross. No, it's not. It's nowhere near as bad as you might think. And your response would be, you don't know what I think. Yeah. Oh yeah, yeah. What's the LCD? X cubed. So you just multiply everything by x cubed. Or if you like it better, you give everybody what they're missing. What's he missing?
X.
You give him an x. Give him
X
X
squared.
a couple x's. Give him
X.
X cubed.
x cubed.
X cubed. X squared.
X.
And then all these basically go away. Because we're going to multiply top and bottom by x cubed. So that procedure's kind of nice. And then you end up with something that looks like it definitely wants to be grouped together over something that looks like it wants to be factored like normal, possibly, if it'll work. Is that cool? I mean, now you just factor the top, do what you can with the bottom, see where it goes. Yeah. Mhm. Okay, so let's get to some new stuff. I think last time we made it. Oh, where did I put my? This 12.2. I think we made it through there, which is 7.1 in the blue book. So, and we actually did a little bit of 12.3, to be honest. And let me see if we remember where we left off last time. So if I ask you to simplify this. Say again?
Is it four at the top or is it four like right on the side of it? Like is that like an exponent of
Fourth
the-
root.
It's a fourth root, yeah.
Okay.
I can bury them in there more. The big thing I want to make a distinction between is it out there like a coefficient,
Oh, okay.
or is it over here like a index? And it's definitely an index. So what do you get? What's the fourth root of 16?
4.
2. Why is it 2? Because it takes 4 2's to multiply. It's not 4 into 16. It's what does it take 4 up to make 16 when they multiply together? So 2. What's the nice thing here?
2.
Yeah, a squared. You just gotta. The shortcut is 4 goes into 8. 2 times. And then 4.
3.
And real quick, how would I rewrite this using a fractional power? What would that look like?
A. 4 over
What has to be on the bottom?
4.
What's always on the bottom?
4.
Roots. I like it. So on the bottom would go fourth root. On the top is the power. Because it's power. So what do you get? What is 8 divided by 4?
2.
That's exactly the way I think, right? I mean, so that's exactly why the shortcut works, because this is a freaking fraction. Freaking fraction. So 4 goes into 8 twice. So the shortcut, don't even write like it, just say 4 goes into 8 twice.
What section is that?
In the white book is 12.2 going into 12.3. In the blue book it's 7.1 thing. Yeah. So here's how we kind of go into the next section. We kind of take the next step up. We say, is it always going to work perfect? What if there were 9 A's in there, for example? Let's look at this way, and then we'll never look at it that way again. We're just going to do it once. How would you write that as a fractional power?
Cube.
9/4.
Right? Power on the top, root on the bottom. What is 9/4 as a mixed number?
2, 1/4.
Yeah, it's a to the 2 and 1/4, right? That's why you don't want to do this way. So, isn't that a to the 2 plus 1/4? And again, I want to remind you guys, I will never do this problem like this ever again. I'm trying to show you why a beautiful shortcut works. All right, just hold on. Let me see if you guys are cool with this. When do I add powers? What must I have done if I added the powers? What must have been happening? It's a weird question to ask, I know, but what would you do here?
5.
Add the powers. So when do you add the powers?
1 multiply.
Is that cool? So I can take x to the 2 plus m and write it instead as x squared x to the m. I can pull them apart like that. Do you guys see? Because math doesn't care which way you go. It does not make judgment on you. You go whichever way you want to. So here I'm going to pull them back apart. This will be a squared times a to the 1/4. So look what happens. I got a squared. What's a to the 1/4? How can I write that as a root?
9/4.
Do it again.
9/4.
No. A to the 1/4. How can I write that as a root? As a radical? What's the root?
4.
4. Now, all this crap is unnecessary once you see how this works. This is so crazy nice. Do you remember how you used to do division? You would say 2 goes into 7 3 times with 1 left over. Right? And of course, we kind of moved away from that. Well, watch this. 4 goes into 9 twice with 1 left. Do you guys see that? And you see why it works? Of course it works that way, because it really is the remainder. Isn't that 1 the remainder? 4 goes into 9 twice with 1 left. We do another one. Once you get that shortcut, it's so stupid nice. So if I had 5th root of a to the 22nd, 5 goes into 22 4 times with 2 left over. So everybody cool with what I did here?
Yes.
Right? And you see what happened? You have a whole 2, and then you have a quarter, which would become a root again. If this would have been a 10th power here, wouldn't this have been 2 and 2/4? And so you would have 2 A's left in there? Okay. So let's do another. So if I had the cube root of b to the 11th, c to the, what's it? 5th. 3 goes into 11. 3 times with 2 left over. 3 goes into 5 once with 2 left over. There. Yes, ma'am.
Could I break it up? You know, like you did the first one, could you make it like 4 and 4 and like 8? Like
Yes, good. That's where I'm going next.
Okay.
I like it.
And then just take
I like
out. Can you do it that way instead of doing that?
Totally. Yes, I like it. All right, so I just want to show you this. It's right off of what we were talking about here for the letters. Now let me do this. Let me talk about how numbers would work, and then I'm going to show you how that would apply to this problem also. So if you don't like looking at it this way, there's another way to look at it. So, what's the square root of 25? 5. What's the square root of 50?
2 by 25.
Some of you guys know where I'm going with that, but my guess would be 7 point something, because square root of 49 is 7, square root of 50 is a little more than that. But the nice thing is, you can do just like you do with fractions. You can simplify this, but I call it reducing the radical. I can break 50 up into
2 by 25.
25 times 2.
And then break
And then break those back up. I love it. So this is the square root of 25 times the square root of 2. Now really quick, right there, some of you guys should be like, why the hell are you allowed to do that? If you have no problem with that, just bear with me for a second. Right? Quick side note. Square root of 25 times 2. Isn't that 25 times 2 to the 1/2 power? Is that cool? We're all cool with that now. Square roots are the same thing as 1/2 powers. What can you do with the power when it's in front of a multiplication? Can't I distribute it to each piece? Correct answer there is hell yes, Jeff. What's xy squared? X squared, y squared. Right? So what can I do with that 1/2 power? I can give it to both of these. What's 25 to the 1/2? Square root of 25. What's 2 to the 1/2? Square root of 2. So I can take a square root of a multiplication and break it up as the product of two square roots. I can break that up. And of course that means I can go the other way. I can put square roots back together. But what's really cool about doing this? What's square root of 25? 5. What's square root of 2? I don't know. Right? So that's what I call simplifying a radical. Why the hell would you want to do that? Besides passing Jeff's 103 class. Here's the first kind of place where that comes in handy. And then we'll talk about the variables. If I had let me ask you this. If I had 3 square root of 3 plus 2 square root of 3, can anybody tell me what that might be?
You
Five.
do the 2
It's a
in
square
y
root.
square root.
Square
You add the
root.
2 in.
I think for a second I heard somebody say something bad thing. If I have 3 of something plus 2 of something, that is 5 of that thing, right? I don't have any square root of 6's anyway. Cool. 3 of these, 2 of these is 5 of these. So what the hell's that got to do with that? Well, what if I had square root of 25 plus 7 square root of 2? Are those like terms? No, I got 1 of these plus 7 of those. But what can I do with this? Oh, not this. I'm thinking ahead, sorry. Make the square root of 50.
25
One,
squared.
2 multiply.
Yeah, you do what we just did over there?
Yeah.
7.
I can simplify this so that we'll hopefully maybe end up being like terms. This piece, of course, is 5. So 5 square root of 2 plus 7 square root of 2? 12 square root of 2. All right, so that's one very good reason to know how to simplify a radical, because then you can maybe combine it with other things running around. Right? So let's take a second and go back to, actually let me do one more like this, and then we'll go back and talk more about the variables. Now those are completely not like terms. You cannot combine those in any way. But you can try to simplify each one. But now it's a cube root. So when I have a square root, I want to break it up into a number I can do the square root of and a number I can't. And then I do the square root of what I can, and I leave the one alone that I can't. So when I have a cube root, what kind of numbers do I want to look for? Perfect cubes. Like 8, 27, right? 64. Things that are perfect cubes. So what goes into 40? Yeah, 8 and 5. So which one of these is going to be left behind? The 5, right? The 5 is going to be left behind. So what do you want to try to divide this by? 5. 5 goes into 135. 27 times. Does everybody see what's happening here? This is here. This is here. I haven't changed anything. I've just rewritten everything.
How come you didn't write the -2?
Say again?
How come you? Oh, okay. Never mind.
Okay. So then, what can I do here? What's the cube root of 8?
2,
2. So I got 2 cube roots of 5. What's the cube root of 27?
3.
3. So here I just got to combine those, right? 2 times 3. If there's anything already out there, it's multiplying by this. So whatever comes out, it'll actually multiply by. So I get 2 cube root of 5 minus 6. Cube root of 5 is how many cube roots of 5?
Minus what?
Negative 4. Cube root of 5. This is just like 2x minus 6x. Because what is cube root of 5? I don't have a clue. So it's going to act just like an unknown, just like a variable does. 2x minus 6x is negative 4x. So 2 of these minus 6 of these is negative 4 of these.
Why is that 2 again, though, right there?
Where?
I got 8. Like, where'd you get the 2 from? See how it's 3?
What's the cube root of 8?
So you pull it out?
The cube root of
No, I don't pull it out. What's the cube root of 8?
2.
2. Bam. All I did was, instead of writing this, I'm going to write what it is. What do we always do in mathematics? We replace 3 minus 5 with negative 2.
Okay.
So forth. Cube root of 8 is 2. Cube root of 27 is 3. I just replaced that with a better representation. I'd much rather use 3 than cube root of 27. Yeah.
Is that squared 5?
Where are we at?
When you were just on the other side, you were just doing that, is that 2 or 2 5? Or?
Yeah, that's 3 squared root of 8.
Oh, it's 3, okay.
And then 3 squared root of 5.
It's the cube root. Cube root.
Yeah,
Yeah.
it looked like a 2 from here.
All right. That's right. If it was the second root, I would never write the 2. Because it's understood to be there. I almost hear a question.
Oh, okay, yeah, I saw 27, 33, 27.
I like it. Cool. So, coming back to the variables. Let's kind of look at them a little bit differently. So, if I look back at that one we did earlier, something like this. I can do these the same way I do numbers. I desperately want you to realize I certainly don't have to. There's a beautiful shortcut. But if you need to, if you want to see that a little bit better where things are coming from, 4 doesn't go into 9, but it does go into 8. And then what would there be here, of course, to make it 9?
1.
1a again. So then you can break this up. It's the 4th root of this piece times the 4th root of that piece. So what's the 4th root of a? 8? A squared. And then the 4th root of a, I don't know. So that's the step you were talking about earlier. There's nothing wrong with basically looking at that the same way I would look at this. This one I would break up. I can't do the 4th root of 32. Well, what can I do the 4th root of? 16. So you break it up into a part you can do and a part you can't. You do the part you can, you don't do the part you can't. So in the same way I would do this number. I can do the 4th root of 16. 2. And I can't do the 4th root of 2, I don't know. Is that all right? So either way you want to look at it, if you look at it as shortcut, 4 goes into 9 twice with 1 left. Bam. So let me give you one with everything going on at once. So simplify this. Let's see. it's a really good idea to have lists like this. If you don't know them already, and I'm hoping our work with like cubes might help you remember some of these numbers. You should know some of the cubes to look for. You should know some of the fourth powers to look for. And really, the only fifth power that could possibly be small enough to still kind of be a part of 96 would be 2 to the fifth power. And what is 2 to the fifth power? 32. And 32 goes into 96. 3 times. Good. Cool. So if you know ahead of time what numbers to even try, that'll make these a lot easier, right? 2 to the fifth power is 32. I'm going to try to divide by 32. If it ain't that, it ain't anything. Because 3 to the fifth power is freaking 243. That's too big. That's, yeah. So I'm going to do this problem 2 different ways. I'm going to do it, I think I'm going to do it first this way, and then I'll do it the shortcut way. So to do it the long way, the nice thing about this way is that everything kind of acts the same. I have to break up this, and of course we just figured out 32 times 3 for that. 5 doesn't go into 12, so I got to break that up into 10 and 2. 5 does not go into 8, so I break that up into 5 and 3. 5 does go into 45, so I can leave him alone. So then the fifth root of 32 is 2, because it takes 5 2's to multiply to be 32, right? 2 to the fifth is 32. And I've got a 3 left in. So look at everything's going to be left inside. All this stuff here is going to be left inside. You with me? All those extra pieces are going to be left inside. 5 goes into 10 twice. 5 goes into 5 once. 5 goes into 45 9 times. Now the shortcut would just say, okay, the 96 you basically have to do this. That's the same step. But then 5 goes into 12 twice with 2 left over. 5 goes into 8 once with 3 left over. 5 goes into 45, 9 with none left over. Right? That whole phrase, with so much left over, kicks ass. You've known that phrase your whole life, and here it makes total sense. They're left over. I just want you guys to kind of see the awesomeness inherent, too. All right, sweet.
So whatever can go into the exponents goes out, and whatever doesn't stays in.
I like it. There's not enough. Here's another kind of nice way to look at this. I can only do the fifth root of something if that something has 5 parts to it, right? 5 of the same thing. You with me? So, where was I going at? What was your question just now?
I was saying that if it can go into 5, the exponent or the number, then it comes out.
I like it. So like this here, the x squared,
Does not.
there's not enough of them. There's only 2 x's. It would need 3 more to somehow come from somewhere. I can't do it. Poor little dude's left inside. It doesn't have enough to get out. There's only 3 y's here. I have to have at least 5. Does that make sense? So if I have a 7th root, I have to have at least 7 of anything for it to actually be able to be done. If it doesn't have 7, it's stuck. So this is my extra. Add 12. That's 2 extra. Too bad for you guys. You got to stay. I can only fit 5. Or in this case, 2 comes out. You guys with me? And I hate that I say comes out, because that always makes people think something can actually just come out of there. It doesn't come out. I can do the root of it. These 10 x's don't come out. The fifth root of x10 is x squared. So I'm actually doing what it's telling me to do. But I can't stop myself from saying that. Yeah.
I don't understand how come this thing out.
Here?
Yes.
Because what's 32 made of? 2 times 2 times 2 times 2 times 2. So what's the fifth root of 32? 2. because it takes 5 2s to make 32. The answer to a root will always be, what does it take this many of to multiply to be whatever's inside? Right, that's why the square root of 49 is 7, because it takes 2 7s to make 49. So the higher powers have to work the same way, yeah.
He's talking about X's on how they came out from the
So I don't know which way you like better. I like just 5 goes into 12 twice with 2 left over. The other way to look at it is, if only there was a 10 here, 5 would go into it evenly. So then you make it a 10 and you put the extra 2 just sitting there. So this way you just kind of see your remainder a little bit better. Whereas on this step, you do have to do a little bit in your head. You got a remainder 3, then you put the 3 down. Remainder. This one you can actually see the remainder, where the hell it's coming from. Yeah.
How do you know you use 32 though, like right off the bat?
Same way that we knew to use, 16 here. That might not be a great example. 25 here. I would not break this up as 10 times 5. Here's the answer to your question. Why I wouldn't do that is because neither one of those is square rootable. I want to break up any number I've got. I want to break it up into a part I can do the root, and then times for whatever the hell else. Right? So if I have cube roots, these are the numbers I'm going to try to use. And if I have something really gross, I don't know. What can you do in your head right now, Jeff? Let's find out. Not much, I guess. So if I had the cube root of, you can do it. Come on, Jeff. 189. Gruesome. Doesn't even look like that goes anywhere. Well, what am I going to try and divide this by? I'm going to try to divide it by 8. Why would I do that? Because 8's cube rootable. So if I could break it up like 8 times something, I could do a part of it. But 8 doesn't go into 189. So then I'm going to try 27. Does 27 go into 189? Hopefully, if I did it right in my head. Yes, it goes in 7 times.
7.
So then I can break it up as cube root of 27 times cube root of 7. I can do this piece, and then that piece just has to stay. That's how I know what to even try. Or you can just start dividing this 2, 3, 4, and then see if the other number is cube rootable. You can do that too. At some point you got to know what you can cube root, what you can 4th root, what can you 5th root. If you don't know that and how to figure it out, you're not going to be able to do any of these problems. Okay. Oh, cool. We got time. That was 11. So let me let you guys try a couple of these real quick here. I could live with that. Yeah, that's true. And I will tell you this. If I have a really big fraction to reduce, what's one mistake that could really easily be made? Somebody does one step, they divide by 2 or something, and they forget to keep going because maybe what they're left with can keep going. Somehow what I just said might apply to one of these if you didn't take enough out. We'll see what happens. If you break square root of 6 up, and to square root of 2, square root of 3, I can't do the square root of either one of those. See, a 2 can't just escape. It would still be square root. So actually go the other way. Put those together. Yep. So how did you guys do this first one here? What did you break it up into? Good. You could do this. You could break it up as 8 and what was it? 8, 1, 6. Does that work? 1, 48. Yeah, 16. Thank you. It takes me a while. But see how 16 has another 8 in it? So it's sort of like reducing what you got, Jeff? Reducing 64 over 80 as 8 over 10, you still have more stuff in each one. Right? There's more that can come out. So the better way to go, so you know 2 cubed is 8, but take the next step up just to check. 3 cubed is 27, 4 cubed is 64, and 64 goes in twice. Right? So you can either do it once, and then you have to actually do this and go further. You have to, just like reducing a fraction, you have to go further. Or you can do it in one big step. If you break it up the right way, 64 times the cube root of 2. Cube root of 64 is 4, because it takes 3/4 to make that. Cube root of 2 is, I don't know. So about number 2 there. Whichever way you want to look at that, if you want to actually break it up so you can see the remainder, or if you just want to attack it with the shortcut, you end up here, 5 goes into 9 once with 4 left. 5 goes into 10 twice with none left. Sweet, so I don't need one that big. Or you break it up, of course you can make this 5th root of A5, A4, B10. You can even make this B5, B5. You can break it up in terms of 5. For each group of 5 B's, 1 B comes out. That's why I got 2 B's out there. Because I have 2 groups of 5 B's. Yeah?
On the first one, if I did 16 times 8, and then just get the 4 square root of 8, will that be wrong?
Oh, it's not a square root, though.
I mean, yeah, sorry.
So you got to be careful. You can't do the cube root of 16. So here, the cube root of 8 is 2. The cube root of 16, you can go further because that's 8 times 2. And then the cube root of 8 would be another 2. That's why I end up with 4. So you'd have to do 2 steps there. Right? Now, on this last one, I'm not picking on anybody, but I get this kind of thing all the time. I get something like that. Where'd that come from, and why is that not right? I get this all the time. So the person who showed me this, don't worry. They took a 2 out of 3, but a 2 can't come out. It can't escape the square root. It would have to still be square rooted. I can only take something out if it's actually square rootable. So I never take something out. I actually just do the square root of it and write the answer.
For number 3, can't you just multiply this?
Yes. So this is the wrong thing to do. The right thing to do is just put it back together. Square root of 60. Now what can you do with 60?
4 times 15.
Beautiful. 4 times 15. And square root of 4 is 2. There you go. And it kind of makes sense. don't each of these have a factor of 2 in them? And think about this, root 2 times root 2, a square root is 1/2. So 1/2 of 2 times another half of 2 makes a whole 2. That's really what's going on there. This guy has a half of 2, that guy has a half of 2. When they come together, they make a whole 2. Right? Hopeful. Okay. So, here's what's going on. We basically made it sort of up to 12.5, believe it or not. So what I'm going to do is on Monday, we're going to start with just firming everything up from what we did today. And then the rest of class is going to be review. So the test is going to go up through section 12.5. You with me? It's supposed to be 12.6. I'm going to make it up through 12.5. You guys?
So what would that be in the blue? In the blue?
Blue book, it would be up through 7.2, 7.4.
So from 7.1.
You guys see what I'm talking about? You have the blue book?
So is that how much homework would we do?
Exactly. That's how much homework is due on Tuesday.
Up to 7.
7-1.
Up to 7.2, 7.4 in the blue book. Up to 12.5 in the white book.
So from 7.1.
If you have a red book, I don't know what to tell you.
From 7.1 until 12.5.
And don't forget, the inequalities section is on here too. It wasn't on the last test, so it's on this test. So real quick, on the practice test, number 5, that's from section 12.6. And whatever the hell it is in the blue book. That's the section we're going to do later, so you don't have to worry about that number 5. That won't be on the test.
A, B, or C. Which one?
All of number 5, none of that will be on the test. That's going to be on the next test. That's from section 12.6.
Are you gonna be here tomorrow?
Tomorrow, don't forget, Fridays, 8:30 to 11:30.
Number 5?
A, B, and C, yeah.
So tomorrow,
A, B, and C?
All 5, yes.
8:30 to 11:30. 38C, 343A. It's on the far side of the 300 North building. I had a decent turnout last Friday, so we'll do it again. Not working?